The ongoing energy transition requires solutions that can be flexible, adaptable, and future-proof to support the evolving systems as the energy transition happens. Today, we are presenting a tutorial about our SICAM SiApp, which is an application that is installed on the SICAM A8000 and where you can develop your own application, such as transformer controllers, optimization of energy storage systems, cost optimization in energy trading, and many more. It is all up to you. Hello, and welcome to this tutorial session. My name is Luis Francisco, Sales and Business Development Manager at Siemens, and today I'll be moderating this event. Now, I'm not doing this alone. Together with me, I am glad to share stage with two of our main experts. Michael Sapp, welcome, and Jorge Diaz, welcome on stage. So, just to give you an idea about the background of these two gentlemen here, Michael Sapp, who graduated from the University of Saarland as an electrical engineer with focus on energy technology, joined Siemens back in 1993 as a technical consultant for protection and substation automation. Working worldwide in technical sales, he has consulted customers and regional partners in protection concept schemes and substation automation systems. Currently, Michael is promoting the SICAM platform and power quality systems. Then we have Jorge Diaz. Jorge, who received his electrical engineering degree from the National University of Colombia in 1994, joined Siemens Colombia in 1998. In 2008, he moved to Siemens Germany, where he has continued working on substation automation system. During the last 4 years, Jorge has dedicated himself to technical promotion of the SICAM A8000 RTU series, where he has become an expert in this family. Thank you, Jorge. Now, knowing the background of our two experts of today, fine-tune your questions. Please note that since you cannot ask the questions directly to them while they're presenting, feel free to type them in the question box or also in the chat. I'll be looking at them and read them out loud afterwards during the Q&A session. Now, a little bit of the agenda from today. So we will first give you a short recap about the concept and components of the SICAM 8 Power Automation Platform and the licensing model for configuration and runtime of a SICAM 8 application. Then we will explain the concept and the technical principle of the SiApp, SICAM application, also using some examples of planned and realized SiApps. You will like that one. Then the practical part of our session called My First Project, workflow to configure your own SiApp. We will demonstrate how easy and straightforward the creation and installation of a SiApp can be. As always, at the end, we will give you a short summary of the benefits of SiApps and how that can, help you in your applications, before we try to answer as many of the questions as possible, of course. This is the session number 4 of the SICAM 8 series, Extended Platform for Power Automation. Now, remember, you can find all the upcoming as well as the on-demand webinars by typing www.siemens.com in your internet browser. Click on Product and Services, then click on Energy, and followed by clicking on Energy Automation and Smart Grid. You have to scroll down a little bit, and then you will go to Webinars for Energy Automation and Distribution System. And there you go. All the available on-demands and upcoming events are available. Now, I would like to welcome our first speaker, Michael Sapp, to join our stage. The stage is yours, Michael.
Thank you, Luis, and also a warm welcome from my side. Some of you may have attended our SICAM 8 unboxing event and the first sessions where we introduced in detail the concept of our SICAM 8 Power Automation Platform and the software applications SICAM S8000 and SICAM Human Machine Interface with Event and Alarm List. In case you missed these sessions, and additionally as a recap, let me start with a short abstract before Jorge and I am presenting you the concept and the details of the SICAM 8 SiApp, meaning SICAM application functionality. What was the reason of extending our proven SICAM A8000 family into a platform concept, namely the SICAM 8 power automation platform. Coming from the way the energy generation and distribution is changing since years and the impact this is having to the projects, what need to be realized, it ends up in a need for speed. How can this be reached? The key is separation and modularity. The SICAM 8 Power Automation Platform can be seen as a toolkit or a construction set and is able to tidily connect the SICAM 8 software, not only with the SICAM 8 hardware, but also with third-party industrial PCs. When installing the software applications onto a third-party industrial PC, we are talking about the SICAM 8 software solution, or SWS. The glue for this connection is handled by the so-called SICAM 8 core. The focus of today's webinar is not only to give you some general information of the SICAM 8 SIAP concept and functionality, but Jorge will show you how easy and efficient you can engineer these applications, and then connecting and installing them, then your own SIAP into the SICAM 8 hardware with the SICAM Device Manager, the engineering tool for all SICAM 8 applications and hardware. As you remember from our earlier SICAM 8 sessions, we introduced already some SICAM 8 software applications. First, the SICAM S8000, containing the core or main RTU functionality, including PLC logics, ID connection via Ethernet-based protocols, and of course, also SICAM 8 core functionality, like cybersecurity and much more. And also introduced SICAM human-machine interface with event and alarm lists. And the SICAM Web, providing a large set of tools for diagnostic, monitoring, and simulating your SICAM 8 applications. These software applications are provided from us, from Siemens, and can be downloaded from our C portal. Our focus for today is to show you what you can do in case you need an application, but it's not or not yet available from Siemens, or is not planned at all. But you need it now, and not in a year or whatever it is planned on the roadmap. Such software applications are called SICAM applications, or short SIAP, and are normally not created or provided by Siemens. But we provide the necessary environment and interfaces to install and run your own software applications on our hardened and secured SICAM 8 platform. The possibility to write your own software applications and install and run it on our SICAM A8000 Linux-based CPUs is not new, but already available and used since years. It is only consequent to include this functionality and possibility into our SICAM 8 platform, and having the possibility of upscaling when using as host a third-party industrial PC with more memory and higher CPU performance. That will allow you to create much larger SIAPs and loading more SIAPs as possible in the past when using our A8000 hardware, the CP8050 or the CP8031. But why do I use will allow instead of allow? When we planned this SICAM 8 webinar series, the roadmap for the SICAM 8 software solution included the SIAP application to be available in the first step. Unfortunately, that is not the case, but has been moved to the next step, coming soon. Nevertheless, the concept and all the benefits can also be shown when using our CP8050 or CP8031 as host for the SIAPs. What do you need for writing your own software application and install and run it on your SICAM 8 hardware? Jorge will show you the needed development environment for writing your application and preparing it for installing it on your SICAM 8 hardware. All additional needed components are freeware. To prepare the SICAM 8 hardware, for example, defining the dedicated runtime container for the created SIAP and the connection to the data and interfaces of the SICAM 8 hardware, you use, as always, our central tool for configuration and parameterization for SICAM 8 components and applications, the SICAM Device Manager, well known to the SICAM A8000 users. For a SICAM 8 project, you need in total 2 different types of licenses. The SICAM Device Manager license for the configuration. This license can be ordered via the so-called online software delivery service. It is a so-called ALM license, meaning it can be transferred and moved with the Automation License Manager. It is modular, and for configuration, for example, the SICAM HMI functionality, you need only to order an add-on in case you already have a license for the SICAM Device Manager. And the same concept, using add-on licenses, is also valid for upcoming new SICAM 8 configuration tasks. So that means no new training will be necessary, as the workflow for new parts of the SICAM 8 Power Automation platform, like for SICAM S8000, are identical to what you already know. The second license will be the runtime license. And there, we are using the same way as with CPOTEC 5, the Function Point Manager. The SICAM 8 software applications can be downloaded from our C portal and be used for 21 days in trial mode. But the unlimited use in runtime mode needs a license. The Function Point Manager is a tool to create or upgrade license files for SICAM 8 software applications on demand within minutes. The handling, respectively, is easy and straightforward. All that is needed is to register and create your Function Point Manager account. When that is done, you can order your SICAM function point budget, needed, for example, for your special project or for all projects done in 1 year. As soon as the ordered function points are credited to your account, you can generate the license file and download it. The license file itself is then transferred via SICAM Web into your device. Some of you may be already using the Function Point Manager, but some not. I want to show you very shortly the easiness of use. After you opened the Function Point Manager and switched to the license file generation part, you first need to enter the serial number of the SICAM 8 target hardware. As you can see, additionally to the A8000 CPUs, the option SICAM 8 software solution is available as target system for installing the software on a third-party industrial PC. But as mentioned before, the SIAP functionality has been moved in our roadmap for the SICAM 8 software solution into the next step. And therefore, it's not yet possible to have this license available when selecting SICAM 8 software solution as device type, especially for SIAP. For other functions, that is working. Under current license types, you can see or could see all the licenses already generated for your target device. Of course, when doing that for the first time, there are no licenses listed there. You need to select under new license types the licenses for the applications you need for your project. For our example, select now the SIAP runtime container support and eventually all the other licenses you need for your project. Press the Add button, and after all licenses are in the list, you can generate the license file containing all the selected application by pressing the Generate License File button. In case you selected the CP8050 as device type, you can add up to 3 runtime container. With the CP8031, only 1. And later, for the SICAM 8 software solution, it will be possible to select even more container. The generated file is after some seconds available, and you can download it and use the SICAM Web to transfer this file into your SICAM device. Okay, before Jorge shows you the workflow for creating a SIAP with the Docker desktop application and the SIAP software development kit, and the installation and mapping with the SICAM Device Manager, I will give you a short overview about the concept behind and some examples where the SIAPs could be used, respectively are already used. The demonstration from Jorge will be done with our SICAM A8000 CP8050 and not with the SICAM 8 software solution running on third-party industrial PCs. Like mentioned before, unfortunately, the SIAP support for installing them on a third-party RPC, what is then called SICAM 8 software solution, has been moved in the roadmap to the next step, coming in July. But the principle and the workflow will be identical. That is the advantage of our platform approach. Okay, let me start now with the overview of the concept and some examples. possible ones, and of course also realized SIAPs. Our SICAM 8 RTUs can be used everywhere in the electrical grid. We call it wherever energy flows, from power generation plants like hydro, wind and solar plants, in power transmission and power distribution substations, and of course also in industrial and transportation systems. Therefore, we are in a privileged position to offer additional services to a lot of different types of customers. The SIAPs will help us to open the door to many of them, because we can offer additional benefits, and that could be decisive in the competition. A SIAP is basically a separate software application that runs on the SICAM 8 hardware environment. In our example, the hardware is the 8050 CPU. The SIAP is fed by the information already available in the RTU or added by additional input-output modules. With this information, the SIAP can perform additional functions such as monitoring, optimization, automation, regulation, recording, and evaluation. There is no need to have an additional infrastructure or additional hardware to run the application. Only the licensing of the runtime environment in the SAP 8050 is required. The process to have a SIAP into a SICAM 8 hardware, like for example the SAP 8050, is straightforward. First, the code of the application must be written, so it will fulfill your special requirements. Then the code must be packed into a software container. That is what we call already a SIAP. Finally, the SIAP must be loaded into the SAP 8050 through SICAM Web. The SIAP can make then use of the features of the SAP 8050, such as rugged hardware, RTU functionality, communication protocols, and so on. With the SIAP, the customer can have a wide variety of applications running, while enjoying the advantages provided already by the SAP 8050. There is no need to use third-party devices to run the application. The application can be devised by the customer to fit exactly to his needs, while having at the same time access to all the RTU information and while taking advantage of the features provided by the SICAM 8 family, like highest EMC requirements are implemented in our hardware. State-of-the-art cybersecurity is always on board. Secured embedded runtime environment is provided. Needed data for the application are already available or can easily be added to the A8000. The communication infrastructure of the SAP 8050 or SAP 8031 can be used. Okay, before Jorge will give you a basic demonstration on the workflow for implementing a SIAP into our SAP 8050, let me show you some specific use cases where the SIAPs either have been already implemented or where they are being considered as a way to fulfill specific goals. With this, we hope you will have a better view of what the SIAPs really are and how they can help you in your projects. As case one, we have a typical example of a SIAP to reduce the time to market. There, a feature was required as proof of concept for a project, and the proof had to be given more or less immediately. We are talking about a requirement that was not available in the SAP 8050 at this time, but had to be available as a demo case before tender submission. Otherwise, there was no chance to offer at all. The required feature was a simple SNMP manager, Simple Network Management Protocol Manager. It was required that the SAP 8050 had the possibility to read information from network devices such as switches and GPS clocks via Simple Network Management Protocol, and to transfer it to the control center through a standard communication protocol. The requirement stated that a demo should be available within a couple of weeks, while the first RTUs would have to be supplied later in around 6 months. This feature didn't exist yet in the SAP 8050, and the development of the feature under standard normal product development would have to. The solution was the following. the development managed to create a small SIApp for the demo from the third-party open-source NetSNMP protocol suite, which has been presented to the customer on time. A second use case, where functions that were not available on the SICAM 8000 hardware can be developed independently from this product lifecycle. An example for this is an in the RTU embedded web-based HMI. When you followed our last SICAM 8 webinar session, you know that this example must be from the past, as we are having now since years our SICAM dashboard HMI and now also the new and improved SICAM HMI. But back then, some competitors had this functionality already available for the RTUs. When this is a must-have requirement, we had problems to offer our products. Also, the required HMI functionality exceeded what was planned at this time in the standard roadmap of the SICAM 8000, meaning the old SICAM dashboard HMI. For this specific project, it was possible to develop an embedded HMI which gets all information from the RTU and publishes it through a web server interface, embedded HMI. In this web interface, all required features were available, such as a general single-line diagram, a detailed bay view with event list, an alarm list, communication, overview, and so on. For that, the SIApp was developed based on a third-party software, which could be loaded into the CP8050. Features like single-line diagram, bay control, event and alarm list, and system monitoring picture could be achieved through this external app, running a SIApp on the CP8050. As use case 3, we have another example where we can add functions independent from the current roadmap on the CP8050. We are talking about an extension of our CP8050 based microgrid controller, a SICAM 8 control application, by the way, by implementing of the Open Charge Point Protocol, OCCP, into a SIApp. This feature, together with the cybersecurity features of the CP8050, aroused an extreme interest by our customers. As use case 4, we have another similar example of implementing functions not included in the current SICAM 8 or CP8050 roadmap. This would be the implementation of the Cumulosity agent into a SIApp. Software AG offers a cloud solution for IoT, Internet of Things, very similar to what Siemens can offer with MindSphere. Currently, the connectivity of the CP8050 to this Cumulosity cloud was not or is not on our roadmap. However, some electric utility companies are planning to connect their RTU to this cloud solution. But through the implementation of this agent in a SIApp, we have the chance to become the brand of choice for such companies. In our use case 5, we show you how the use of SIAPps is not only protecting the application know-how of the user, but additionally saving him time and money to develop and maintain the hardware where their application will be running. With the SIApp, our partners have the possibility to develop their own controller applications. One example is the development of a SIApp working as a control unit of our generation system. These control units using the actual operational values of active and reactive power, voltage and frequency, and based on them calculate through a complex algorithm the proper set points to reach the desired network status. These algorithms include valuable know-how that must be protected. By implementing them on a SIApp, the owner of the logics provides only the compiled application while the know-how remains by him. As use case 6, we have another example of a SIApp to protect the application and the algorithm know-how and to use reduced hardware to implement the required functionality. We are talking about an automatic voltage regulator, or also called AVR, for transformers. It is very interesting for other companies offering automatic voltage regulator functionality to use additionally our RTU hardware as platform for their algorithm instead of or additionally developing an own hardware platform. Since the RTU already has all the required process information to perform this automatic transformer regulation, if the required algorithms are implemented on a SIAP, the RTU could perform this task. These algorithms are protected, which would also be a unique selling point in this case, as well for us and also for the company with the automatic voltage regulator know-how. That all started as an idea together with one of our business partners and really has been realized. In the meantime, every year, several thousand automatic voltage regulator controllers based on our SICAM 8 hardware, CP8050, and the third-party algorithm hosted there in a SIAP are sold by our business partner. The next use case shall demonstrate that only the imagination is the limit regarding what can be achieved with a SIAP. To reduce turnaround times in pre-development, complex processes can be simulated in a program called MATLAB. Siemens Corporate Technology are currently developing a software development kit called SDK to create MATLAB applications running as SIAPs on the CP8050. In this way, complex processes can be simulated within the SICAM A8000 environment for testing complex algorithm in a realistic way already in pre-development stage. The final use case we have for you today is about an automatic switchover of loads in photovoltaic plants to prevent negative pricing penalization. Many electricity market regulators implement pricing schemes where the price paid for provided energy depends directly on the forecasted demand. It can be that the set energy prices turn negative, which means that the owner of a photovoltaic plant have to pay money if they inject energy into the network. It will get paid if they consume energy. A SIAP could be configured to automatically read the actual energy prices from the website of the market regulator. Based on the value and the sign of the actual price, the SIAP can decide whether photovoltaic energy should be injected into the network or loads should be connected, which means that would mean additional payments for the owner of the photovoltaic station. I hope you are as excited as I am to see now the demonstration from Jorge, showing you the workflow and a small example of the creation of a SIAP. But before I ask Jorge back on stage, I give you a quick inside view of the technical concept and the architecture inside the SICAM 8 CP8050 CPU host, where the SIAP is running. This picture shows you how the technical solution works. Each SIAP will run in a dedicated SICAM application runtime container. Up to 3 SIAPs can run in one container. Alternatively, you can install additional up to 3 runtime environments container on a CP8050. So it would be possible to run one SIAP in each container. In any case, you can have maximum up to 3 SIAPs running at the same time on the CP8050 hardware. The SIAP have access to the RTU information via various methods, either via the integrated application programmable API interface, but you can also route the information via communication protocols using an internal virtual Ethernet connection. The SIAPs can also exchange information with other SIAPs using also this internal virtual Ethernet connection. Or you can have contact with the exterior from a pre-selected LAN port of the CP8050. Please note that if you not using the CP8050 but the smaller brother or sister, the CP8031, only one SIAP license will be allowed. That means that only one SIAP runtime environment will be available. As outlook for the upcoming next step for SICAM 8 software solution, an upscaling to have more and larger SIAPs running on third-party industrial PCs can be as expected. But now it is time for the practical part of our session called My First Project, Workflow to Configure Your Own SIApp. Paul, the stage is yours.
Thank you, Michael. So I will now try to show you, to demonstrate how you can implement a user-defined SICAM application, or for short SIApp, with the available tools that are freely available in the web, in the GitHub web page. The best way to demonstrate this is with a practical example that you could follow step by step on your own later. What is the example that we will create today? So basically, we have a CP8050 already configured with some process information, a single line diagram, some switching devices from one single bay 1. And we want to install here a SIApp based on a demo project, which is available in the software developer kit provided in GitHub. So the example that we will do today includes how to okay, how to download from GitHub the software developer kit and the Docker desktop software. I will show you how you can download the software from there without any problem. Then, how you can compile this software in the software developer kit and create the SIApp as you want it. Then, the next part is how you can create with this software. You can prepare the device manager configuration with this software. So this means in device manager, you load the prepared SIApp there, and then you just prepare all the configuration of the RTU, load the configuration in the RTU, and then when everything is fine, you just load this configuration in that you can test the configuration in the computer. So this is the basic example that we will demonstrate today. Okay, so let's do it. So the first step that we will see is how we can download from GitHub the software developer kit and how we can install the Docker desktop in your PC. So I'm having some hardware issues here, sorry. I'll try to, maybe it's the problem with the pointer, so. All this is done basically by accessing with your computer internet directly via a web browser like Google Chrome, Firefox, Microsoft Edge. Let's see how it would be with Google Chrome. So you have connection with internet, you open your web browser, and then you just need to type the URL that gives you access to the software developer kit of the SIApps under GitHub. You type it there, access it directly, and then you will see all the software developer kit here available for you. And then this first step that we will do is how to install the Docker desktop. So we need to have a link to download the installation file. So we will just scroll down, and we will see here under system requirements. What are the requirements of the PC where you are going to run the Docker application or the Docker desktop? So you will need a PC that has Windows Professional 10, at least version 1803, or you could have also a Linux-based PC. Either way is possible. Now, if you are working with Windows 10, you will need to install the Docker desktop. If you are working with a Linux PC, you need to download the Docker application. And then the requirements also mention the Python 3, but basically this is also included in the Docker desktop, so no need to take care about this step. We want to download the installation file or Docker. So we just click here on the Docker desktop. This link here, and then we are forwarded to this link where we can download the installation file for Docker desktop. So regular procedure, you just click here, and the software will be automatically downloaded into your PC. Once the installation file has been fully downloaded, we just need to install it, run it. Standard Windows procedure, just double click on the installation file, and then it will be run in the computer, the installation. This process may take some minutes, and after it is ready, you should get the message indicating that the installation has been successfully done. Then you can close this window, and now you should start the Docker desktop application in your PC. How do you start an application in a Windows 10 computer? You can go to the Windows icon in the taskbar, and then you just type and look for Docker desktop. Then you will find the icon to start the application. You just double click on that, and then it will start. Upon the first time when you run the app, you will have this message, this Docker subscription service agreement. Docker desktop used to be free of charge for all users, but now they have changed the service agreement. Now it is still free for small businesses and also for private use or for educational purposes. For large companies, they demand a fee. This is a small fee. This is not an issue actually for a medium to large company, so it's pretty much affordable, and I think it will not be a problem for any company that wants to try that. In this case, you just accept the service agreement, and then Docker desktop would be started. Once it is started, this window is closed automatically, and you should check before you proceed to the next step if the Docker desktop application is running. How can you check it? So normally in the taskbar, you can check through this whale with the Docker symbol that Docker desktop application is running. So with this, we have finished the first step, how to download Docker desktop and install it in your Windows PC. Now, let's go to the second step, how to download the software developer kit and how to compile the available demo project there to create your user-defined SIApp. So let's see how this step is done. Again, we will go back to Google Chrome. Same web page where we had the software developer kit available. The easiest way, in my opinion, to download the software developer kit is to download it as a zip file. To do that, you go on top here to the green button where you say code. You click there and you select download zip. You click there and the file will be downloaded in your PC. You can then copy it to a directory in your hard drive where you want to have the software developer kit, and you just extract this zip file. Like with software like 7-zip, for example, right-click, 7-zip, extract to, and then you will have all the software developer kit locally installed in your computer under a folder. We can just browse to this folder, click in there, and then we will see all the structure of the software developer kit. Important things are there that we need to consider. You will see this function, this program, build.py. So this is basically a script from Python that will let you compile, pack, generate the SIAP. We will be using this file in some seconds or minutes. We will also see here some folders. And one of these folders is this demo project. This folder has all the code required to generate this demo project SIAP, which is basically a very simplified web browser where you can just send information from the RTU, display it in this web browser, and you can also write back to the RTU some commands maybe. So let's take a quick look at what is the structure that you find inside of a SIAP project. In this case of this demo project SIAP. We go inside and we will see there is this Docker file .arm32v7 file. This is a text file, and every SIAP project that we have, any SIAP application, should have this file. Okay, a file with this exact name. This SIAP provides all the instruction to Docker Desktop to create the SIAP with the code that we want. We will see that there are also some folders there. In this case, one app folder, where actually the instructions of a web browser are defined completely there. We have the HData API folder, where all the drivers, the library for the application interface between the signals in the A8000 and the signals in the SIAP are allowed, okay, are made possible through this library. And we have an SRC folder where all the instructions for the SIAP actually are done. All the code actually is programmed in this file. So basically, the SRC has code that is referencing the app application and also the HData API. In this Docker file .arm32v7 file, we have normally all the instructions. So if you look at this, you will have something like this, where you can find always in the first line an indication of what is the system that is the target system for the SIAP. So the SIAP will be prepared to be run on this type of system. And the target system is an S8 system. And for the S8 system, the system architecture is an ARMHF or ARM hard float architecture. So with this line, we ensure that the created SIAP will be compiled against this architecture, so it will run there. Then we have these lines where the source code included in this file is packed into the SIAP, is copied into the SIAP. And in this instruction, actually, the source code is compiled, actually. This is the file where it creates the SIAP. Finally, there is one line where some additional things that are not required anymore will be cleaned to make the code smaller. These are regular steps that you find always in this file. Now, once the file is ready, in this case, then we go back to the folder where we have the software developer kit. And here, we will compile, we will create the SIAP. How do we compile the SIAP? For that, we need to open a command prompt application, like, for example, the Windows PowerShell application. Again, in Windows, how do you open this Windows PowerShell? Basically, you go again to the Windows icon in your computer, and you look for Windows PowerShell. Then you can open this command prompt. It will be by default locating the current user in the folder for that user. See users, and then this is the user of the name of the current user logged. But we want to be located exactly where the demo project is located. So in the location of our software developer kit. So we just browse in the application in the Windows PowerShell by typing cd, which means change directory, and then the path of where we are located. We type that, enter, and then we can see that we are located there. Next step is to use this build.py script. We can run this script by typing Python, then build.py, and then the name of the project, demo project. We click there, and then the Docker desktop will compile all the SIAP. And if everything went according to plan, you will see at the end that it has been successfully generated. It will also indicate where it has been successfully generated. You will see that there is a new folder that has been created once you have compiled your first project for this software developer kit. You will see this build folder. Inside of this build folder, we will have the actual compiled SIAP. You will also see here some important information, like the recommended configured SIAP slot size. This information we will have to keep in mind, because this will be important when we are defining the environment in SICAM Device Manager. So now we will just check inside of the build folder. We will see that there is a folder, demo project, and inside we find the SIAP. This is our SIAP. This is the file that we will have to implement in our SICAM Device Manager process. So you have seen it has been nothing complicated. Of course, just to write the code, this is something that is a work for a software developer. Normally, standard configuration languages like C++, Java, or Python can be easily used to write the application that you need. As long as they are against the proper ARM HF architecture, it should be fine. Any developer will have no problem reading the software developer kit instructions and providing and write the application that you really need. Now that we have done this first part, the SIAP preparation, we will go to the next step, which is the preparation of the A8000 to let the application run there. All these steps are done with the software SICAM Device Manager. So let's do it. We will go now to SICAM Device Manager. In this case, we are using the latest available version as per today of SICAM Device Manager, which is the version 4. You will see there we have a project, and we have the configuration of one CP8050, where we have already the bay 1 configured with this connector, circuit breaker, air switch, some measurements also there for this bay. And we want to display this information in this demo project SIAP. So how can we implement this? The first step is to import in the SICAM Device Manager project this SIAP that we just created a minute ago. How do we do that? To do that, we go to the upper left corner. And then we click there. And then we check here under SIAP. And here we will see one button to import the SIAP. From there, we just need to browse into the folder where the SIAP is stored. So in this case, software developer kit is this one, and then build, demo project, and the SIAP. We confirm, confirm, and we have the SIAP, the demo project SIAP is in our SICAM Device Manager project. Step 2 is to prepare, to import, to define the SIAP runtime environment in the configuration. So we will go to the configuration of the CP8050, and then we will go to this box, application configuration and licensing. And there we have, beside the regular firmware of the CP8050, we will have this option, SIAP runtimes. And there we can define for the CP8050, as Michael mentioned before, up to 3 different SIAP application runtimes. For each one, you will need a license. So in this case, we will only need one. So I click here, add new row. Then I have SIAP runtimes, and it is offering me the SIAP runtime 0. I can select it to be the 1 or the 2 as well. In total, 3. So 0 is fine by me. We leave it like that. This is the name of the SIAP runtime application firmware, and this is the version. Nothing to be done here. I will just confirm. And we have then this line here. So we have one SIAP application runtime available then in this RTU. So on the next step, we go back home here in the configuration, and we would like first to check the hardware settings of the RTU, because we want to connect this demo application, this is a demo project SIAP, to one specific port in the RTU. So an external device with a web browser can access this demo app through this port. This port, due to cybersecurity reasons, shall be used exclusively by the SIAP. So no other application of the 8000, so no other communication protocol or so on, should be using this port. So we have to check that. But the port should be enabled in the RTU. So let's do the checking first. We will use for this example the port CI0X1. Let's see what this is. We will go to the hardware first. So we are talking about this port here. And we want to make sure that this port here will be available first for configuration for the SIAP. So I will just mark the whole module, and I will go to the settings. And in the settings, I can see that the port has been enabled. Then I can use this port for the SIAP. This is the first checking I should do. Then pass, perfect. The next step is to check that this port is not being used by any other process in the RTU. So how do we check that? We go back home, and then we will check under communication, where we define the internal use of the ports in the RTU. And here we can see that on the LAN interface, these 4 LANs are being already defined here. But I can see that the 2 LAN ports in the CP are being used. And for the additional module CI0, only the ports X3 and X5 are being used. This means the port X1 is free. This is perfectly fine. So we are sure that we are allowed to use this port in our SIAP. So now that we have done this small check, we will go back home and we will go to configure the actual runtime environment in the RTU. So we go to the SIAP box. On the SIAP box, we will see that since we inserted one SICAM application runtime, we will see it here. So we click there. First, we will see the name of the SICAM application runtime environment, and we can see that it is already defining a RAM limit for this SICAM application runtime environment. There is a limited amount of RAM that can be shared by the RTU to the different SICAM application runtimes. There is a limit in total of 300 megabytes that could be shared among all the available SICAM application runtimes, up to 300 in total. So if we could apply, or if this is the only SICAM application runtime, we could assign the 300 here. If we had 3 different SICAM application runtime environments, maybe we could split it 100 each. Of course, it doesn't make sense to provide all the available RAM to one runtime environment that does not need that much. And this demo project is not really big. So for the time being, I would select maybe 100, and this would be more than enough for our current purpose. So now that we did that, I can just proceed here to define the port that will be used by the SICAM application runtime environment to connect it to external world. So this other application will be able to access our demo project. So I will just add here one port. I select here the port that I want to use for the SICAM application runtime. The one that we already discussed that was free, that was available, not used for internal purposes. Perfectly, this one is fine. And then I set an IP address to this port. So from now on, through this port in the RTU will belong exclusively to the SICAM application runtime and will be used by any external browser to access our demo project SIAP. Now, we have defined the SICAM application runtime environment, but we need to then define the SIAP that will run there. This we do here in this part, SIAP. We can have maximum 3 SIAPs in one CP8050, okay? So the procedure to add one SIAP is as normally in Device Manager through this plus signal, button, sorry. You add it and it is saying, okay, this is the slot 0. We could have 2 more, 1 and 2. So remember, we are talking about the slot 0, and here under name, there is this arrow, which means I can select something. Let's look what is there. I can select the demo project that I imported in the first step in Device Manager, the SIAP that we compiled also before. So by doing this, I am telling the system, okay, so in this SICAM application runtime, this demo project will run. Here is the definition of the SICAM application runtime. Here is where I select or assign the SIAP to the SICAM application runtime. Further parameters that we need to check here. Flash memory. This is very important. Which value should we set there? We received actually a hint when we created the SIAP. The Docker desktop was telling us which was the perfect parameter for that, at least 53, so we could set it here perfectly. Next parameter, fast format. Would say yes is better. In this case, the starting of the SIAP would be faster the first time after installing it. And also, I could select the SIAP behavior in case it is terminated by an error. Maybe I would like it to try automatically to restart. With this, we are done defining the environment of the SICAM application runtime in SICAM Device Manager. But there are still some things to be done because we have not set tell in the system which signals should be used by this SIAP, which signals should be written into the SIAP, which signal should be written back by the SIAP. So let's do it. How do we do that? We go back to home, and then we will go to RTU signals. Then, for those of you who are familiar with our previous version of SICAM Device Manager up to the version 3.9, there we had always on the left a structure of the RTU showing the different protocol elements and hardware. And on the right, we had all the signal list available in the RTU. In the version from the version 4, this has been mirrored. Is no longer like that. In this case, we have the architecture is on the right side and the signals are defined on the left. But the procedure is exactly the same. The important assignment is done in the middle. So let's assign for this SIAP all the signals that belong to the Bay 1, because this is what we want to display in this browser. So I can use this very wonderful feature in Device Manager, which is called the flash filter. I can just select under name the text Bay 1 and apply the flash filter. So I can see then only the signals that have under this name column the text Bay 1. And then I can select all of them and map here. They should be mapped to the S8000 RTU master firmware. So I mark them all, and through this button, I will map them. Now, here I have signals, some currents. These currents shall be written from the RTU to the SIAP. Also, the positions of these switching devices, Q0, Q1, and Q8. This should be written into the SIAP. So I take only these signals that should be written into the SIAP. And remember, the SIAP was in the slot 0. So I mark here processing type and assigned SIAP 0 input. So signals that are to be written into the SIAP are marked as SIAP input. Assign them all. And now we have the commands left. The command should be written from the SIAP, so from the web browser we're connecting, to the RTU, to the 8000. So in this case, I mark all of them, and processing type, I select SIAP 0 output. Assign to them all. I can check here then again the filter to see which signals have been assigned to the SIAP. Some as inputs and some as output. We still need to define the addressing, the name, the ID that these signals will have in the SIAP environment. So for that, I will go to parameter. And under parameter, I will see under SIAP 0 input, this column name. So I define a name for every signal there. And this is the ID of each signal in the SIAP. This is how they will be displayed in this demo browser, for example. And the same for the outputs. I define a unique name for each one. Once we have done that, we are pretty much done with the configuration of Device Manager for the SIAP. What is left is just to load this and test it in the RTU. How do we load this? Okay, so we have connection, of course, between this engineering computer and the 8000. So we just go to upload and download. With a proper username and password. Then the Device Manager is telling us that there is a difference in the engineering data and, of course, a new SIAP runtime environment and a new SIAP have been defined. They must be loaded. So I select here, upload to device. Then it will be uploaded into the RTU. Then afterwards, the RTU will request to confirm that a restart will be required. And after some time, everything should be like that, meaning that the SIAP, that configuration has been successfully loaded into the RTU. Before we test the SIAP, maybe we can check already in SICAM Web if everything looks fine. So we can go here back to Home and go to SICAM Web. Again, access with username and password. And then, for example, we could go to this box, Applications. And in Applications, we can go to Running Applications. And there, you will see that the SICAM application runtime is running, and also the SIAP is running. if you access the SICAM web maybe really fast after you have loaded it, it can be that it is not running yet. So you could see maybe starting here, which is also quite normal. You maybe need to give some time. If it doesn't say fail, then everything should be fine. So we are pretty sure it should be working. How do we test actually our demo project? So we need to connect, of course, a computer to this CI X1 port, and then with a browser like Google Chrome, we just access the IP address of the RTU directly. The IP address that we define for this SICAM application runtime. In this case, 172.16.08. And once we do that, this simple web browser will be shown, where we can see this green connected means the connection has been established by the SIAP. And on the receive, we will see all the signals that we define as SIAP 0 input there with the name, with the addressing that we defined, the data type of each signal, and the current value. Also, the quality is displayed here. And you can also, if you go to the send tab here, you can send commands. For example, if we want to close this disconnector, we just click here, write the value 2 means close, and click on set. And then if we go to receive again, we should see that this position has been switched to 2, which means closed. In this case, if you go to send and you send also the closing of the circuit breaker for this, in this system, in this simulation, actually, there was also automatic currents flowing, and you could see the values here. So you have a full functioning interface here. In addition to that, if you go to graph, you could see the current values that are coming in this SIAP input for each one. And also under events, you could see all the logging of the signals coming into the RTU. So basically, this is the demonstration of how you can implement a user-defined application from Docker desktop to the RTU to make it work with this demo project. This will be really helpful for you, I hope. And now I will leave Luis to summarize basically what we have seen today.
Yes. Thank you, Jorge. Let me just put this here. Before actually saying anything, I know that we are over time, but what I see here is that the attendance, I mean, there's a high attendance to this webinar, so I would like to continue, right? So first, thank you, Jorge, and thank you, Michael. I think that it has been impressive. How do you show how easy it is actually to engineer your own SIAP application, right? So now let's check now on the questions, because I think this is important. And for that, I would like to invite you both to come with me. And I'm gonna pick just a couple of them. One that is on the chat, I mean, it's available to everyone, is can we use the SIAP for converting 104 to Profibus without external converter?
In principle, of course, that would be possible, but we are having this, let's say, IC104 protocol, or additionally to the Profibus or Profinet IO, are available in the CPD50. Yeah, and in principle, everything is possible, no limitation of the SIAP, but be aware, we are not writing it from Siemens. That is let's say, a tool to provide our customers with their software developer a tool to create their own applications. It's not planned from our side to write a SIAP for converting IC104 to Profibus DP or Profibus IO. That it's not our plan, because we have it available.
Understood. I mean, it is a standard. I mean, for the person who asked that question, it is just available.
Yeah.
So, right. You wanted to say anything?
No, that's okay.
No. Okay. So there's one actually talking about yourself. There is the SDK, so the developer kit. Is there any cost required for that?
Basically, the software developer kit of the SIAP is available to download free of charge from the software developer kit webpage available in GitHub. So we are providing this free of charge. You can download it, no cost attached. What you need to consider if you are a member of a large business is the licensing for the Docker desktop, of course. But this is for exactly for Docker, the definition of their software. Okay, it's not expensive anyway. And of course, you will need the license of SICAM Device Manager to configure the RTU to receive the SIAP. And the runtime environment also should be licensed in the SIAP, in the RTU or in the S8 system.
Okay, perfect. Another question that is here is regarding the runtime containers. So the question is, if you have, if you can download 3 times the runtime container and you can run 3 SIAPs, so you have maximum 9. So it is about the capacity. It is about the capacity. No,
you cannot have 9 applications in a 8000.
Okay.
You can have in a CP8050 3 SICAM applications, 3 SIAPs.
So the limits are not adding up. They must be considered separately. You can have 3 runtime containers, and you can have 3 SIAP applications.
Okay.
But not 3 times 3. So that are limits that you cannot add up. Yeah, in each container you can have up to 3 SIAPs, but then this limit it's already considered.
So up to 3.
You may ask then yourself, if I can with one SICAM application runtime already have 3 SIAPs running, why should I spend 3 licenses for runtime applications? Then what would be the advantage in this case? Every SIAP will be running in this SICAM application runtime, okay? If you have 2 SIAPs, they are both running on this SICAM application runtime with shared resources. If you have an error code in one of the SIAPs, it might be that the whole SICAM application runtime is shut down. So all the SIAPs that are running on this runtime environment will be affected. If you have different runtime application container, then if you have a coding problem in one of the SIAPs, only this one will be affected, and the other 2 would continue to run without any issue. That's it.
Perfect. There you have your answer. Another one, and then I'm actually having the last one. The next one is just came in. Does the SDK modify the original container provided to it?
When you download the software developer kit, so it includes some demo projects, okay? It is included there. You can modify them as much as you want. You can copy one of these folders where we did this demo project and make changes, whatever, and then you're making changes in a new project. So, no, basically it doesn't matter what is in the software developer kit available remains in the software developer kit. You are just making changes locally in your PC.
No, then perfect. I would like to call it, because I know that we are over time.
We're not over time. We have foreseen 1.5 hours. Not an hour like always.
Okay. Then let's continue. Let's continue then. Okay, this said a new one says, as per the presentation, it was set as 100 megabits RAM, which is more than enough. But how do we know what is the best RAM to be set in the configuration? Is there any calculation like 100 signal?
So basically, as I displayed, this 100 megabyte RAM was for the SICAM application runtime, just reserving it up to 100. For the individual slots in this application, as I show you in Docker desktop, when you compile, when you create the SIAP, normally you receive a recommendation of the size of the slot. So this is one way where you can get this information.
Okay.
And of course, a developer with good knowledge of his tool might also have an idea of which type of memory will be required depending on the data that will be exchanged or so.
Okay, perfecto. There's here another question. So to access runtime by a web browser, it is possible to implement with user password or RBAC, so role-based access control. Any comment on that one?
Yeah, for let's say for each physical interface of the CP8050, of course, we are, let's say, standard SICAM web, of course, that it's possible to use here role-based access control. And additionally, even with an LDAP server Active Directory, that it's possible with standard SICAM web access.
Yes, but you have to consider in this case, you have the RTU, and as I mentioned, the LAN port of the SICAM application runtime is separated from the LAN ports in the RTU. So this means the traditional role-based access control that we have configured in the A8000 does not apply to the port in the for the SIAP. But of course, you can write in the SIAP whatever you need to write. So you can also write your role-based access rules there.
Exactly.
Right? So yes, you can, but it will not be by default with the device security settings of the A8000 because it's separated.
There you go. And there is another question that goes also in that direction: is can SIAP be used instead of CFC logics to program more complex control programs?
Yes.
Yes.
It's done. It has been done in the past, especially for control application, whatever. But to be honest, yeah, if you use the internal, let's say CFC logics, yeah, then you have more memory. Then maybe it's in the SIAP available. But in principle, of course, all the logics can be written also in a SIAP.
Yeah, this is you have only a different language. It could be written in C++, Python, whatever, but you can do with this information whatever you want.
And that's, that's actually another question that I see here is about the programming language. You show, as you mentioned, C++ and Python. I mean, is really open to anything?
Yes, it depends. Of course, a developer will know that he most likely includes some headers, some libraries, so whatever in the project, in his software developer, in his project to be included, so it can use all this coding, this language. But yes, they can use basically any possible programming language.
Okie dokie. Now I would like to have also another one here is, are you planning to develop a Peterson coil regulator in the SIAP?
No, we are not planning it. Why? Like mentioned, for the automatic voltage regulator, that it's a special application know-how. Of course, we have it also because we are working here with business partners, and we are planning to have it inside of our CPTEC 5.
Yes.
That is planned there. Why to develop a second time on base of CP8050? But of course, our partner, like for the automatic voltage regulator, can use the same approach to use the application know-how to write its own SIAP, and it's know-how property. But we as Siemens are not planning it, or yes, energy automation. Like mentioned, the SIAP, it's a tool where only for some special reasons we are using it. That's using this application, this API interface for our partners, for our customers to use their own software development, to install their own application know-how. And we are planning it on CPTEC 5 to have this Peterson coil. And so
perfect. I mean, I would like to use that question actually afterwards then to trigger the summary. But this is, that specific case, it is exactly why we're putting outside this platform. So if you have, let's say, a shunt reactor, and you have your also shunt resistor, and you have all your network conditions, you know your voltage, you take your measurements, you have your impedance, you have your reactance, anything that you need to actually use it as an input, as has been shown by Jorge. So you have the controller, you have the inputs, the inputs goes to the software, right? And then you get your commands or outputs. I mean, and you don't have to wait us, or you don't have to wait any other manufacturer. And this is very important here. anything that is not available, you can tailor it made to what you need. Right? And that said, I would like to really summarize now, because it is, there are several benefits that you can benefit from having actually SIAPs. First is the SICAM 8 hardware, like the CP8050, to incorporate the SIAPs. So, spare parts is something that you can reduce dramatically, right? So the patching of the SIAPs can be easily performed through SICAM Web, reducing maintenance downtimes. And this is also a very good advantage. And I think also that since the RTUs are distributed, as we said, whatever energy flows through SIAPs, running on different, distributed hardware, the customer could also achieve increased availability. So that's a great benefit there. And through the SIAPs, the functions of the RTU can be adapted to your local needs, exactly what we said. Don't wait till a feature is available. Develop it with your own developers, and make that as part of the applications that you need before anything is on the market. So also, just consider it's also allow you to implement features on the RTU system in a record time, right? So we already went through the Q&A. I just wanted to thank you, audience, for the questions. There's more questions coming in, and thank you, Jorge and Michael, for the answers. For those questions that hasn't been answered here, you will receive the answer in the email you use to log in, okay? And I saw also the question in the chat. Remember that you will have access to this recorder just right after this ends, so you have it on demand. And you can also go to www.siemens.com and look for webinars, and you will have all the on-demands available and also the new ones. So we appreciate you giving us feedback. We hope that we were able to, give you a good glimpse of the features and benefits of these SIAP applications. So that said, we hope to welcome you soon to another webinar. There's another session happening later, and you should see right now a QR code on the screen, which will lead you to the SICAM 8 webinar series. So we hinted at the earlier. So until then, stay safe, take care, enjoy the rest of the day.
Cheers.
Goodbye to
Bye-bye.
Ciao, ciao.